Hello everyone, this is Sai Geeta. Currently I am pursuing my BTech degree at Srinivasa Ramanujan Institute of Technology. So today we are going to learn about linear search and binary search with example. So while we are going to learn about linear search and binary search, we are going to learn about introduction to searching, linear search, how linear search works, linear search example, program on linear search time complexity, binary search, how binary search works, binary search example, program on binary search time complexity and conclusion. Firstly, introduction to searching. What is searching? Searching is the process of finding a specific element in a list or array. It checks whether given element is present or not. Searching technique are used to retrieve the data efficiently. Types of searching. When it comes to types of searching, there is two kinds of searching. They are linear search and binary search. So firstly let's learn about linear search. It is also called as a sequential search and it requires no need for stored data. It checks element one by one. It starts from the first element and moves to the last. Let's learn how this linear search works. Nothing but algorithm for linear search. Starts from the first element. Step 1 is. So when we given a list or array to it, it starts from the first element and that means 24019 is an array. When we given a key element 0. So it starts from 2. It compares the key element with each element. That means it compares the 0 with 2 with 0. It's not match. If it match, then it return the position. If the end of array reached element not found, it stops. So linear search example. So as we discussed in the previous slide, here is an array that is 10, 25, 30, 45, 50. Search key element is 30. It checks that 10 with 30, it is not equals to 30. Then it again go to 25. It searches the 30 with 25 with 30, it's not matched. So it's again return to the next element, that is 30. Here it is equal to the 30 is equals to the key element we given. So it is found at position 3. So it returns the element found at position 3. So in previous slides we learned how the linear search works and algorithm of linear search. Now let us see the program on linear search. So here we declared header files and now when it comes to the main, so we declare array n key I found equals to 0. Firstly it asks the user to enter number of elements. So as we entered the number of elements present in an array, it asks the elements of an array. Enter the elements of an array. So as we entered, it asks the key element to search in an array to enter it. So as we entered, if array I equals to key, then it performs the searching. That means it searches whether the entered element is present in an array or not. If it is present, then element found at position it returns the position of that element. So if found equals to 0, that means if the element is not found in an array, then it returns the element not found. So return 0, that is the usual. So when it comes to output, enter number of elements. So we have to enter the number of elements that an array consists. So it is 5. Enter 5 elements. So 10, 20, 30, 40, 50. So enter element to search. As I entered 30, that means I want to search the 30 is present in this array or not. So as 30 is present at the position 3, it returns the element found at position 3. Now let us see the linear search time complexity. That is time complexity of linear search and its advantages and disadvantages. So the best case time complexity of an linear search is big O of 1. The worst case is big O of n and average case is big O of n. So when it comes to advantages of linear search, it is simple to implement, works on unsorted data and sorted data. That means the data which can be arranged in any order, that is ascending order or descending order. So it is works on the unsorted or sorted array. So disadvantages, that means slow for large data. That means it takes us so much time for large data when it comes to as we given large data. So now binary search. Binary search means efficient searching technique. When it compares to the linear search, binary search is efficient searching technique, works only on sorted arrays. Unlike linear search, it only works on sorted arrays. That means elements have to be arranged in the proper way. Divides the arrays into two halves. Compares the middle element with the key. So let's see how binary search works. Algorithm for binary search. Set low, first step is set low equals to 0, high equals to n minus 1. That means low is initialized to 0, high equals to n minus 1. Here n means size of an array. So we have to find the mid value of an array. So to find the mid value, we have to add low plus high, that and it has to divide it by with 2. If key equals to array of mid, that means if we entered value, that means entered key element is equals to the mid value, it returns the directly it returns the position. If entered key value is less than the mid value, it sorts the left side of an array. That means as we sorted in this binary search, as the elements are already sorted, it automatically sorts from the left half. So if the key element is greater than the mid value, it sorts the right half. Repeat until found or low. Repeat until we found the element or low less than greater than the high. So for better understanding, let us see the binary search with example. So we entered then sorted array in the ascending order 10, 20, 30, 40, 50. We had to search the key element 40. So as to find the mid value, the formula is low plus high by 2. So low equals to 0, high equals to n minus 1. Here the size of an array is 5. So n minus 1, 5 minus 1 is 4. So 0 plus 4 by 2. We get the position mid value at position 2. That means 30. So it searches the mid equals to, so here mid is greater, here 40, that is key element is greater than the 30, that means mid value. So it searches the right half. So when it comes to 30, it checks the 40 with right half means 40. So if we find the element, so it returns the element found. So for better understanding, let us see program on binary search. So we see how the binary search works and the algorithm for binary search. So let's see the program of an binary search. So as we declared an array and enter the elements of an array, if the low equals to 0, as we discussed before, it initializes the low equals to 0, high equals to n minus 1. If low is while, it uses the while loop. So while low less than or equals to high, so it performs the following operations if low equals to high. So if mid it is correct, then mid equals to low plus high by 2. If as we discussed the three conditions in the previous slide, that is the mid value is equals to key mid value less than or greater than key element. So it checks the first condition, array mid equals to key. So if it is correct, it is okay, then it satisfies that condition, then it returns elements found at position. So if it is not, array mid value is less than the key element, then low equals to mid plus 1, else high is equals to mid minus 1. So it applies these three conditions. At last it doesn't found the element in an array, it returns the element not found. That means if found equals to 0, then it returns the element not found. Let us see the output of the previous program. So enter number of elements, that is 5. Entered 5 sorted elements, that is with it asking the enter the sorted elements, that means they have to be arranged in the ascending order or descending order. So 10, 20, 30, 40, 50. So entered element to search, so we had to enter the element to search, that is 40. So it applies the previous logics as we discussed, that is calculates the mid value and it checks the mid value with key element. If it is equal, it returns the position. If it is greater than, it searches the right half. If it is less than, it searches the left half. So here the mid value for these elements is 30. So key element is greater than the 30. So it searches the right half. So it searches from the right half element found at the position 4. So time complexity of binary search. Time complexity of binary search is best case is big O of n, worst case is big O log of n, and the average case is big O log of n. Advantages of the binary search is very fast for large data and efficient. So as we discussed for linear search, it is slow for the large data. So in that cases we can use the binary search. And disadvantages of the binary search is it's only work on the sorted arrays. When it comes to linear search, it works on both sorted arrays and unsorted arrays. So finally the conclusion of an linear search and binary search is faster, but it needs the stored data as we see. Linear search is simple but it's slow process for large data. Binary search is better for large data sets. Thank you. I found